Good day everyone. Today, we from Group 28 will be presenting on the topic of chemistry in the food industry. Our presentation will explore how chemistry plays a crucial role in various aspects of food science and technology. We will cover five key areas including the fundamentals of chemistry, chemical kinetics, bonding, atomic structure, and thermochemistry to better understand their applications in the food industry. Before we begin, let me introduce the details of our course. Our course name is Chemistry with course code DAM13102. Our beloved lecturer's name is Technologist Aida Binti Muhammad. Now, let's move on into the content of our presentation. Before diving deeper into our topic, let me introduce the members of our group who have worked together to prepare this presentation. First, Darwin, second, Shama Sundar, third, Dharineshwaran, fourth, Vishal, and lastly, myself, Yashwindran. Each of us has contributed to researching and preparing the different sections of this presentation, ensuring a comprehensive overview of the chemistry involved in the food industry.
Greetings everyone. I'll be explaining about the fundamental of chemistry and atomic concept. There are four parts in this, and the first one is states of matter in food. As we all know, there are three types of states of matter, which is solid, liquid, and gas. All these states of matter changes during a few types of processes, which is freezing, boiling, or breaking. As we know, solid are bread, liquids are milk, and for gases, examples are carbon dioxide in soda and baking. And the second part is atomic concept. Atoms consist of protons, neutrons, and electrons, as you all know, and it can be combined to form a molecule, for example, glucose. And next is the essential elements, which includes carbon, hydrogen, oxygen, and nitrogen, which is considered as macronutrients, while for micro it's calcium, iron, and potassium. The difference between macronutrients is it's a nutrient that's needed in a large amount of quantity in our body, while micronutrients is a nutrient that is needed in a less amount of quantity in our body. Next, I'll be talking about chemical reactions. There are a few reactions, which is Maillard reaction, which is browning in baked and grilled foods, while fermentation is changing sugar into alcohol, for example, bread and beer, while oxidation is rancidity in oils, and lastly is reduction, which is preservation using antioxidants. Finally, I'll be talking about enzymes in food processing, where enzyme acts as a biological catalyst, for example, cheese making, and then break down proteins, which is, for example, meat tenderizing, and last but not least is converting starches to sugar, for example, fruit ripening process. Thank you. That's all for my part.
Now I'm going to explain about the chemical bond in the food industry. First, let's look at the covalent bond. This bond forms when atoms share electron, creating strong and stable connection. In food, covalent bond are what link with the molecule of the protein, carbohydrates, and then the fats. For example, the peptides bond in the protein determine their structure, which affect how they behave during the cooking and digestion. Similarly, covalent bond in the carbohydrates impact the texture of the food like bread or pasta. Next, we have the ionic bond, which occur when one atom donates an electron to another, creating a positive charge, opposite charge ion that attracts each other. In food, ionic bonds are most commonly found in the salt and minerals. For instance, the table salt or sodium chloride is held together by ionic bond. This bond influence the flavor of the food and also acts as a natural preservative by controlling water activities. Now let's move on to the hydrogen bond. These are the more weaker bond that occur between the molecules, but they are incredible important in the food system. One of the most significant role of the hydrogen bond in the water behavior. Hydrogen bond also stabilize the structure of the protein and and carbohydrates which affect the food texture. For example, they help from the gel-like structure in pudding or smooth consistency of the yogurt. So all these bond, covalent, ionic and hydrogen works together to determine how the food ingredients combine, reacts and behave during the cooking. As a conclusion, chemical bond is fundamental to the structure, texture and behavior of the food. From the covalent bond that stabilize nutrients to ionic and hydrogen bond that impact the flavor and texture. Understanding this interaction allows us to innovate and improve the food.
Now, let's explore the role of chemical kinetics in the food industry. Chemical kinetics is crucial for understanding how various factors affect the rates of reactions in food. These factors include temperature, concentration of reactants, catalysts, which is also known as enzymes, and surface area. Temperature influences processes such as caramelization and spoilage, where higher temperatures speed up these reactions, while lower temperatures help preserve food for longer. The concentration of reactants also plays a role as increased reactant concentrations can accelerate reactions like fermentation and browning. Catalysts such as enzymes like amylase used in bread making speed up reactions, enhancing texture and flavor. Additionally, smaller particles with increased surface area allow reactions to occur more quickly due to greater exposure. In food preservation, chemical kinetics helps control reactions, slow spoilage, and extend shelf life. For example, the Maillard reaction produces the golden brown color and rich flavors in baked and fried foods. Enzymatic reactions are responsible for browning in fruits and vegetables, while non-enzymatic browning is critical for taste and appearance, such as in caramel production. Overall, understanding these reactions is essential for managing food quality, texture, and safety effectively.
My name is Dharaneshwar Divakaran. My matrix number is AA240357. I'm going to talk about the electronic structure of atom. Nucleus and electrons. The nucleus contains protons, not positive charge, and neutrons neutral, while electrons have negative charge, occupy energy levels or shells around the nucleus. Next, electron capacity. Each shell holds a maximum of 2n to the power of 2 electrons divided into subshells SPD, FSPD, FSPDF, and orbitals, with each orbital accommodating up to 2 electrons. Filling rule. Electron, Electrons fill shells and orbitals based on the Aufbau principle, lowest energy first, Pauli exclusion principle, unique quantum states, and Hund's rule, maximize unpaired electrons in subshell. Chemical properties. Electrons configurations such as carbons 1s to the power of 2, 2s to the power of 2, 2p to the power of 2 determine valence electrons influencing bonds and reactivity. Noble gases are inert due to fully occupied outer shells. Application and trends. Understanding electron structure such as explains periodic trends, atomic size, ionization energy, electronegativity, and practical applications like designing semiconductors and the colors in fireworks caused by electron energy transition. That's all.
Greetings to
Thanks.
my honorable lecturer. I am Vishal Venkatesan, and now, hereby, I'm going to present you about thermochemistry in food industry. So, what's the definition of the thermochemistry? Studies heat and energy changes in chemical reaction, ensuring the food safety, quality, efficiency. So, the application is by cooking and baking, the heat causes reactions like caramelization and the Maillard reaction. So, for preservation, freezing and pasteurization regulate the microbial activity. Energy efficiency, optimizing heating, cooling and drying in production. For chemical reaction, there is two: endothermic, which is melting, and exothermic, which is frying. So, these reaction during processing. The key terms here is specific heat capacity, food ability to absorb the heat. Enthalpy changes is energy release or absorb in reaction. And third, the exothermic and endothermic. Exothermic is heat release like grilling, and endothermic is heat absorbing, melting. So the fun fact here is the Maillard reaction in bread baking releases the heat, which is exothermic, while melting chocolate absorbs heat, that is endothermic. Hereby, thank you so much.